Welcome to Maths for All. I'm Aisling Flynn. This is Trigonometry 1.3, the Sine Rule. So the Sine Rule applies and can be used with all triangles. So before now we've just worked with right angle triangles, but the Sine Rule we can use with any type of triangle, including right angle triangles. Just a note on how we're going to label the triangles. Okay, so in a given question you can label your angles in a triangle A, B and C. Okay, so whichever is A, B or C may change, but the opposite side to the angle with capital A as its label is known as small a, and the opposite side to angle B is known as side B, and the opposite side to angle C is known as small c. Okay, and that's true in all the triangles. So angle A is opposite side A, angle B is opposite to side B, and angle C is opposite to side C. Okay, and the same goes even for a right angle triangle. B opposite B and C opposite C. And you can choose to label A, B and C as is convenient for your question. We'll see that in a while. Okay, so what is the Sine Rule? So here's the Sine Rule. Okay, we have a triangle there labeled as we did on the previous slide, and it says in any triangle ABC, the side A over the sine of the angle A is equal to side B, so that's their lengths, over the sine of angle B, which should be equal to side C over sine of the angle C. So on the top here we've got the lengths of sides over the sine of angles. Lengths of sides over the sides of angles, and so it is a ratio, and it compares the lengths of the sides to the sine of the opposite angle, and the ratio between all sides and the sine of the opposite angle, they should be the same throughout the triangle. Okay, or you can use the inverted version, whereas it has the sine of the angles on top over the length of the sides on the bottom. Okay, and because they're ratios, because they're comparisons, they will still be equal. Now it looks a little unusual there in that you have 3 items, 3 fractions and 2 equal signs. Well, really we would only use 2 pairs at a time, so 2 pairs of angle and sides at a time, and we create an equation to solve whatever problem we're doing. Okay, and we can use either version of the rule depending on what the unknown is. Okay, in our question you will see that in a moment. The Sine Rule appears in your formula and tables books on the trigonometry page 16. Okay, so if you look at trigonometry of the triangle, here's our labeling. Okay, and the Sine Rule you'll find here, and like I said, you'll only ever use 2 at a time. Okay, and it can be found there. So let's use the Sine Rule now to calculate the length of an unknown side. Find, correct to the nearest whole number, the length of the side marked X in the given triangle. And the advice here is to choose a version of the rule to place the unknown at the top left of the equation, and we'll see why that's useful now in a minute. Okay, first things first though, we're going to match up angles and opposite sides in their pairs. So clearly 62 is opposite to X, so 62 goes with X and 34 goes with 12. Okay, and what we're asked to find is X. Alright, so putting x in the top left of the equation means I'm going to put the lengths of the sides on top. So I'm going to use the version where a over sine A equals b over sine b. And you can write that down for the examiner as well. Okay, so my unknown side is x, and that's over the sine of its matching angle, which is 62 degrees. Okay, and that ratio should be equal to, now if one side is on top, the second side should be on top also, so 12 over sine of 34 degrees. Okay, so have a look at that. In this case we're putting the sides on the top and the sine of the angles on the bottom, and should be the same on the left and the right. Okay, so remember this equation is a comparison. Okay, so what can we do next? Well, we can evaluate the two signs if we wish. It sometimes helps students to do this first. Okay, and sine of 62 on my calculator gives me 0.8829. Now there's loads more decimal places. Really, for accuracy you should include as many as possible, and definitely more than what you're asked for in your answer, which is the nearest whole number. Okay, and we have 12 is going to be divided by sine of 34, so we input that and I get 0.5592. Okay, try that on your calculator, make sure you're getting the same answer as me. And now we're going to solve for x. So we have an equation, there's only one unknown, so it is solvable. Okay, we might do the division on the right first, so we'll leave that be for a moment. So I'm going to do 12 divided by 0.5592, which gives me 21.4592. And then to solve for x, I'm going to multiply left and right by 0.8829. 0.8829, because 0.8829 divided by itself is 1. And this will give me an answer for x. And I get 18.9463. And remember, the question asked for the length. Correct the nearest whole number. So x is equal to 19. Alright, so pause that and review. Does my answer make sense? Well, 12 is opposite a small angle, 34, so 19 should be opposite a bigger angle, which is 62, so yeah, okay, it's reasonable. Now here's another one. Find correct to the nearest whole number the length of the side marked x in the given triangle. Okay, so first of all, like before, we're going to find our pairs. Okay, and we need two pairs to compare in the equation. So 68 is opposite x, so 68 goes with x, and we have 79 should go with this. Now that's a problem because that's empty. Alright, so I don't think we can use the 79 degrees. What about this 9 here? Well, that goes with this empty angle here, which we don't know either. However, we can use our knowledge of triangles to fill in that empty angle. Okay, the three angles in a triangle should total 180 degrees. Okay, so if we take from 180 degrees the other two angles, 68 and 79, well then we will know the measure of the missing angle. So 180 take away those two is 33 degrees. So I can put that in there. So a little extra step there to go this time. So my pairs are 9 goes with 33 degrees and x goes with 68 degrees. We're going to use the version where the sides or the lengths are on top because our unknown x is a length. Okay, so x over sine 68 degrees should be equal to 9 over sine 33 degrees. Okay, we can evaluate the sines if we wish. So sine of 68 is 0.9272. Sine of 33 is 0.5446. All right, moving across, I'm going to do the division on the right hand side. So 9 divided by 0.5446 is 16.5259. And finally, I'm going to multiply left and right by 0.9272 because 0.9272 divided by self is 1, so I get 1x equals to 16.5259 multiplied by 0.9272 gives me 15.3228, and reread the question correct to the nearest whole number. So I will say we want to stop after the 15. 3 is less than halfway, so it's closer to 15 than 16. So we'll say x is 15. Does it make sense? Well, the smaller side 9 is opposite the smaller angle 33, so the bigger side 15 should be opposite the bigger angle 68. So yeah, it makes sense. Now, moving on now, this time we're asked to use the sine rule to find a missing angle. Find the measure of angle A correct to the nearest degree. Okay, so just like before, we're going to match up the sides and angles first. Okay, so angle A, that's what we want to find out, goes with side 14, it's opposite, and angle 53 degrees goes with side 12. There. Okay, so there's our two pairs, and out of the 4 things in the pair you can only have one unknown, which is grand. Okay, and this time our unknown is an angle, so we're going to go with the version of the sine rule where the sines of the angles go on top. Okay, next we're going to put in the values we do know. So we don't know angle A, we'll leave that be. We do know the opposite side is 14. We do know what angle B is. In this case, even though it's labeled C in the picture, I'm using it as B, that's fine. So sine of 53 degrees goes with 12. Okay, so what can we do here? We can evaluate the sine of 53 degrees. And I get a value of 0.7986. Next, I'm going to do the division on the right hand side. 0.7986 divided by 12, and we get 0.06655. The next step is to isolate sine A. A is our unknown, so we start to move things away from it. So we're going to multiply left and right by 14, because 14 divided by 14 is 1. So we get sine A equals, and when we do the multiplication on the right hand side, 0.06655 by 14, we get 0.9317. Okay, so the sine of our missing angle A equals 0.9317. How do we find out how many degrees A is? So what we have here is we have the result for a sine calculation, and we need to work backwards to find how many degrees are in A. So at this stage, and it was in the previous lesson, we're going to use the sine inverse. So we're working in reverse. Sine inverse function. So our angle A will get the answer if we do sine inverse of 0.9317. So you're asking the calculator what angle gives us an answer for sine that is 0.9317. So on your calculator you'll press the shift button and the sine button, gives you sine inverse 0.9317, and I want you to try this as well. Press equals and we get 68.7013 degrees. Okay, and we're asked to give our answer correct to the nearest degree. Okay, so we want a whole number, we want to stop at the decimal point. The next digit 7 is more than halfway, 5 or bigger, so this angle is closer to 69 than it is to 68, so we'll give our answer as 69 degrees. Alright, so there we see us finding an unknown angle. We've used the alternative version of the sine rule where you put the sine A on top. You can use the other one also. It just, by putting your unknown in this position up here, the top left hand corner, you've less manipulation, you've less moving around of things to get your answer. Now it's time for you to try some exercises on that.